Hello, friends. A warm greetings and welcome to my YouTube channel. First of all, I thank you for taking your valuable time and also an interest in this topic. In this video, we will be learning about another commonly used heavy metal index estimation method called metal index, or in short MI. For your convenience and information, the content of this video constitutes of the following sections. First, we will talk about the general concept of heavy metals in the environment, and there are different types of index method developed by different researchers for determining the level of heavy metals in the environment. And metal index, or MI, is one among those different index method. And after which we will then dive deeper into the topic. That is the metal index, or MI. First, we'll see a brief introduction about this index method. Then we'll see the formula of the metal index method and see how the index method is classified. And last but not the least, I'll demonstrate to you the hands-on calculation of MI using Microsoft Excel. To begin this video with, first of all, let us briefly try to understand what are heavy metals in the environment. Heavy metals are the naturally occurring elements found in the earth crust. Due to this, heavy metals are found to distribute in different living tissues of an organism and also in various components of the environment. However, under natural condition, the concentration or level is estimated to be very low or insignificant, with values ranging in part per million or in part per billion. Therefore, at such a low level or concentration, the heavy metals have no significant health impact or pose no potential health risk to any living organisms or the environment. Few examples of heavy metals are arsenic, aluminum, chromium, copper, cadmium, mercury, nickel, lead, and zinc. On the contrary, with modernization, industrialization, and advancement of human civilization over the past decades, various anthropogenic activities such as mining and presence of electrical and electronic industries, electroplating industries, pesticides industries, fertilizers industries, plastic industries, pulp and paper, pharmaceutical industries, industrial emissions, vehicular emissions, to name a few. These activities are known to release quantum amount of various pollutants, including heavy metals, into the different component of the terrestrial as well as aquatic environment, thus resulting into the exponential rise of heavy metals level in the environment. Now, when in the environment, these heavy metals later find their ways into the living organism through soil, drinking water, food, fish, air, etc. And through the process of bioaccumulation and biomagnification, these heavy metals are found to produce an adverse effect on plant, animals, and even on human health. So with this basic explanation, we can conclude that it is vital to monitor and assess the level and the degree of heavy metals in the environment. Generally, concentration of heavy metals is estimated or studied in sample of air, soil, water, plants, animals, sediments, etc. And for studying these, the analytical methods and estimation techniques adopted are totally distinct and different from one another. However, after analysis, for easy understanding, the analytical data or results obtained are subjected to different heavy metals indices of choices. These are the list of different widely known heavy metal index methods which have been used by different researchers. In case if you're interested in the other index methods such as geoaccumulation index and the heavy metal pollution index, kindly check my YouTube channel. So in this video, we'll be talking about the metal index method. First of all, this index method was introduced by Massey and Sini in the year 2004. This index method is one of the simplest index method developed for determining the degree and level of heavy metals present in any surface water or groundwater sources of interest. Because using this index method, researchers can quickly find out the current status of water quality with respect to heavy metal levels of contamination. Next, for determining the level or the degree of heavy metal contamination in any surface or groundwater sources of interest, metal index is calculated using the formula displayed on the screen, which is metal index or Mi is equal to the summation of Ci divided by Mac, where Ci is the concentration of the ith heavy metals in the samples analyzed, and Mac is the maximum allowable concentration of the ith heavy metals. So, how do we obtain these? The Ci, or the mean values or the mean concentration of the ith heavy metals, is obtained after the water samples have been analyzed. Whereas for maximum allowable concentration or MAC, there is no specific definition of it, but it generally implies to the maximum prescribed limit or the highest permissible value assigned to any heavy metals present in the water samples. So the next question is, where do we obtain the MAC values for different heavy metals analyzed in the water samples that we are studying? The answer is MAC values can be obtained from different international or national agencies which prepare the prescribed limit for different heavy metals in the water samples, such as the World Health Organization standards, the US Environmental Protection Act standards, the Bureau of Indian Standards, or Indian Council of Medical Research standards, or the respective countries' standard limits, and many other more. Now, the first step is selection of the international or national agency that is appropriate for the study, and it is from these selected recommendable agencies where the MAC values or reference values for different heavy metals will be obtained. The best way is to compile the standard limits of different heavy metals in the water samples in one table so that it will be convenient and easy for the researchers to do the computation or the assessment later on in the calculation stage. So this is the table which I have compiled all the different heavy metals present in water samples adopting WHO, EPA and BIS prescribed standard limits. Next, there are few points researchers need to remember when using metal index method. Point number 1 is, for calculation purposes, all the heavy metals mean concentration or the values that you'll be using must be expressed in terms of part per billion or microgram per liter. And the next point is, the choice of selecting the MAC values is totally dependent upon the researchers or the type of the study. Why? Because MAC values differ from one recommendable agency to another and also from one country to the other. And the next point to remember is in this video specifically, the MAC values that will be used for calculation of metal index has been obtained from the Bureau of Indian Standard or BIS 2012. And last but not the least, and in some research papers, you'll come across that MAC is sometimes expressed as the SI. So if you see the formula of summation of MI is equal to the summation of CI by SI is the same with that of MAC. Okay. Next, let us see the metal index classification or categorization. Initially, when this index method was developed, there is no specific categorization or classification assigned to it as such. Instead, there is only a general expression, that is, they say that if concentration of the heavy metals in the water samples is higher than the MAC values, then the water quality is said to be contaminated with heavy metals. However, later on, in the year 2005, CRO et al. Developed the metal index categorization and classification. And according to CRO et al. 2005, water quality has been classified into 6 different classes, starting from class 1 to class 6. And for each respective classes, the water quality is designated as, for example, class 1 will be very pure, class 2 pure, class 3 slightly affected, class 4 moderately affected, class 5 strongly affected, and class 6 as seriously affected. And depending upon the calculated MI value obtained, the water quality can be classified into one of the 6 different classes. For example, let's say you have water samples, and after analyzing the MI values of the water samples, let's say the MI value obtained is 4.2. So if you check from this index classification, you see that 4.2 fall under the class 5, so which indicate that the samples is strongly affected with the particular heavy metals analyzed. However, again in the year 2010, Bacon et al. Modified the CRO et al. Metal index classification or categorization. He further simplified it by saying that when the calculated MI values is found to be greater than 1, then it signifies that the water samples is polluted with heavy metals, because MI values greater than 1, which is the threshold warning for the increased concentration of heavy metals in the water samples. However, if the MI value is said to be less than 1, then it signifies that the water samples is safe or free of heavy metal contamination. Next, we will move on to the last part, that is the calculation of the metal index method using Microsoft Excel. So for demonstration purposes, let us assume that we are conducting a study on monitoring the heavy metals in a water samples. Let's assume that 7 heavy metals are studied, and these 7 different heavy metals analyzed are arsenic, cadmium, copper, lead, mercury, nickel, and zinc. So these are the symbol of these different heavy metals analyzed. And in our study, let's assume that 3 different sampling stations were selected for collection of the water samples. And from these 3 different sampling stations, water samples were analyzed for these 7 different heavy metals. Let's assume that these are the data that we obtained after the analysis of the heavy metals. So for station 1, the arsenic content is 269.58, for station 2 is 91.20, for station 3 is 39.46, and similarly for all the different heavy metals for different sampling station. If you still remember, for calculation purposes, all the analytical data must be converted into part per billion. So I've already converted this data in part per billion. Alright. Next. So if you remember from the formula of the metal index, it is given as summation of Ci by MAC, where if you remember, Ci stands for the concentration of the ith heavy metals after sample have been analyzed, and MAC is the maximal allowable concentration. So which means that these data here, all these values within this red box here, represent the Ci value of the different heavy metals studied. Okay, so now once you have the Ci values, what is next required according to the formula? The next will be the MAC value. So maximum allowable concentration, if you remember again, are obtained from different international or national agencies which you have selected for the study. And as I told you earlier, that MSc for this calculation is obtained from the Bureau of Indian Standard. So if you remember the chart that I have arranged, remember this? So it is from here you will acquire your maximum allowable concentration. So first of all, have a look here. For arsenic, arsenic AS, where is arsenic here? Number 3, arsenic is acceptable limit is 0.01, permissible limit is 0.05. So the maximum allowable concentration, which means that this is the value that you need to bring here. So which means that 0.05 is the maximum allowable concentration for arsenic. Okay, so next, cadmium, cadmium CD, here you'll have only one value, which is 0.003, and here there's no values, so the maximum allowable concentration for cadmium will be 0.003. all right. Next is copper, Cu, copper. Where is copper? Copper is 0.05 acceptable limit and 1.5 is permissible limit. So which one is maximum? Maximum is 1.5. So 1.5 is the maximum allowable concentration for copper. Similarly, you do it for lead. Lead is number 4. 0.01 is the maximum number, so you just have to put it here, 0.01. Similarly for mercury. Mercury is number 1 here, 0.01 again, 0.01. Next is for nickel. Nickel is number 6, 0.02, 0.02. So that will be your MAC. For zinc, you see the zinc, there's 5 is acceptable limit, 15 is permissible limit, which means that 15 is the maximum concentration, so you can keep here 15. So this is how you will acquire your MAC values for different heavy metals that you have selected in your study. Okay, now the thing here is, after you acquire or compile these values, now remember, for calculation purposes, all values should be it the concentration of the heavy metals in the water samples or the MAC, they should be converted into ppb. Okay, so since they have to be converted into ppb, so now these are all in mg per liter or ppm, so you have to convert them in ppb. So it's very simple, just take this value here, just put an equal sign here. So the arsenic MAC values in mg per liter into 1000, that will give you the values in ppb. So you'll get all the values here in ppb. So these are the readings that you when you carry out the calculation for metal index. Now once your Ci and the MAC values are ready, now you can initiate the calculation procedures. So the calculation for this index method is very simple, beginning with the arrangement in this manner. Go station wise and place the heavy metals analyzed, and then the mean concentration or the Ci values, the maximum allowable concentration, and then the metal index, which is the equals to Ci divided by MAC. So what you have to do here, for you have to fill the Ci values for station 1 first. So go to this cell and copy these values from here and paste it in this Ci column. Similarly, you have to follow the same for station 2. And station 3, copy and paste it here. Next, MAC values are these, right? So copy these and you have to click here, paste spatial, click on values, OK. Similarly for station 2, paste spatial, values, OK. Paste spatial, click at values, OK. So now you have obtained the Ci value and the MAC values. So finally now we'll do is the calculation of the metal index. So if you see this metal index calculation, summation of Ci by MAC is the formula here. So what you have to do is just put equal sign. Ci is this divided by MAC, this one. Click enter key and then drag for the other heavy metals. So this is the metal index for different heavy metals analyzed. Similarly, you have to do the same for station 2. Put an equal sign. Ci values is divided by the MAC values. Enter key. And then you obtain for the other heavy metals as such. Similarly, for station 3, Ci value divided by MAC. Enter. You get the Mi value of the respective heavy metals analyzed. So now once you have done this, so the formula, what does it say? The formula of metal index is summation of Ci by MAC, which means you have to sum all these different Ci by MAC. Okay, so they click on this cell, go to auto sum and then click on sum and then press enter key. So this is your summation of Ci by MAC for sampling station 1. So similarly, you have to repeat the same procedure for sampling station 2. Go to auto sum, enter key. So this value here will be your Mi values for station 2. And similarly, go to auto sum, enter, and this will be your Mi value for station 3. So now for the final part, prepare something like this so that will be easy and convenient for you. So this is your metal index value for station 1. So copy this and paste it here. Click on values. Okay. Similarly, for station 2, copy it, paste spatial values here, and last but not the least, for station 3, copy it and paste it here. So now for different sampling station, you have obtained the metal index value, which is this. So based from these values that you obtain now, using the metal index classification and categorization. So for station 1, which is 12.33, so you'll see that 12.33 is belong to which class? Belong to class 6. So which is 6, which means that the water samples is seriously affected. You see? And then for station 2, the Mi values is 5.09. So 5.09 is falling in between 4 to 6. So which means that the station 2 is constituting a water of class 5 and is strongly affected with heavy metals. Okay, last but not the least, for station 3, 3.6. So 3.6 is between 2 and 4 mi value. So which means that the water sample is falling under the class 4 or is moderately affected with heavy metals. So this is how you obtain the results about the level of contamination of heavy metals in any water samples selected for analysis. So based on our findings, we can conclude that the water quality in sampling station 1 is seriously affected with heavy metals contamination, and the water samples in station 2 is strongly affected with heavy metals, and the water sample in station 3 is moderately affected with heavy metals. So with this, I hope this video will help you to understand about the metal index and how to calculate it, and later on how to interpret the results. So with this, we have come to an end of this video. So if you find this video helpful, and if this video is uh, guiding you and assisting you in understanding this metal index method more clearly, I will request you to please kindly share, like, and subscribe to my channel. So once again, thank you for your love and support. God blessed.